Welcome to Flipped Classroom. This unit is Algebra and we are looking at solving linear equations. Our learning intention is we are learning to solve equations by applying the same operation to both sides. And our success criteria is I am successful when I can create equivalent equations, solve linear equations without brackets, and use substitution to check my answers. So to start, let's look at a couple of equations and see if we can notice anything similar between them. So I've got three equations here, 4x equals 20, 3x equals 15, and 7x equals 35. Now we can look at all three of these equations and we know that they are equivalent to x equals 5. And we can check this. So we can go 4 times 5 equals 20. We can look at 3 times 5 is 15. And 7 times 5 is 35. When we're solving linear equations, we need to look at equivalent equations. And equivalent equations are when the same operation is performed on both sides of the equation. Now this might be when we're adding or subtracting the same number from both sides, or it might be multiplying or dividing both sides by the same number. Now we can't multiply or divide by 0 because we know that multiplying by 0 will cancel everything out and both sides will equal 0, and dividing by 0 can't be done. It causes an error on your calculator and we don't divide by 0 in normal equations. So to solve a linear equation, we need to create equivalent equations by doing what's called the inverse operation, and we sometimes call this backtracking. So the reason it's called backtracking is we work backwards through the order of operations to cancel out each operation and make an equivalent equation that is slightly simpler. Now when we get to the end of this, we can check our answers by substituting in our answer back into the original equation and check that both sides are equal. So inverse operations are really important to find out, and there are a lot of inverse operations, but we're only going to worry about a couple of them. Inverse operations are an operation that reverses the effect of another operation, and we call this cancelling out. So the examples that we're going to be looking at today are adding and subtracting. So we know that they are inverse because 15 minus 6 equals 9, but 9 plus 6 equals 15. And we know that that minus and plus are the opposites. Multiplication and division are also inverse operations. One we're not going to look at today, but it's good to keep in your head, is square and square root operations. So we know that 5 squared is 25. But the square root of 25 is 5, so they're inverse operations. Let's look at some examples here. Now we've got a couple of 1 and 2 step operation examples here. On the left, I'm going to write down my thinking, and on my right, I'm going to be putting what I would put into my book to show my teacher I understand this question. So my first step for this is I need to identify the inverse operation. So what I do is I first off write down the question. So our question is 3x equals 9. Now I look at that 3x and I know that it's 3 times x. So my inverse operation for that times is divide. So my next step will be dividing both sides by 3. And I've written this as a fraction. So I've got 3x divided by 3. And I've got 9 divided by 3. We've done the same operation to both sides. Now, the 3 for the 3x and the 3 in the denominator can cancel out each other. And what we're left with is just x equals 3. Now, let's check if our answer is correct. So we will substitute it back in. So we get 3 times 3 equals 9. And we know that 9 equals 9. Let's try this with the next question. So again, our first step is identifying the inverse operation. So again, I've written down my equation and I can see that it's x over 5, and I know that a fraction is similar to division. So what I'm going to do is I'm going to multiply both sides by 5. And again, I can cancel out the 2 5s on the left-hand side, and all I'm left with is x equals 40. So again, we check our answers by substituting it in. 40 over 5 equals 8. And we know that that simplifies down to 8 equals 8. And everything is correct because both sides are the same. Now let's work on question C. Again, we're identifying that inverse operation. Now we've got a plus 8 there. So the opposite of plus 8 is going to be minus 8. So I'm going to subtract 8 from both sides. And then I'm going to simplify it so I can cancel out that plus 8 and minus 8. And I'm left with just minus 4. Now I can check that answer by substituting it back in. So negative 4 plus 8 equals 4. And I will use my number line to work out that negative 4 plus 8 is 4. So I've got 4 equals 4, and that is all okay. You'll also notice we're working down the page here with the equal signs under each other so that the teacher can see each step of my working. So question D. This one is a little bit harder because there are 2 steps to this. So again, I'll write down my equation, and I need to work out the first operation that I'm going to be removing. And the way I do this is I'm going to use my order of operations, and I know that that plus 1 is the last thing that's going to happen to my equation there. So that's going to be the first one that I need to remove. And the opposite of plus 1 is minus 1. So I'll minus 1 on both sides. Again, they can cancel out, and all I'm left with is 2x equals 6. So again, I'm going to find the inverse of that 2x equals 6, and that is going to be dividing by 2 for both sides. And what we're left with is x equals 3. Again, I can substitute this in. So 2 times 3 is 6, plus that 1 is 7, and we can see that both sides are the same. Okay, let's do one more example. This one's going to be a little bit harder, and we'll take a couple more steps, but the steps are still the same process. So again, I've got my thinking and my writing. So my first step, I will write down that equation and work out what is the first operation that I need to inverse. Now, with order of operations, usually addition and subtraction are last, but we'll notice that this whole equation is divided by 7. So if I put a number into x, the first thing I do is multiply, then subtract, and then that divide by 7. So because we're backtracking, we need to remove that divide by 7, and we remove that divide by 7 by multiplying by 7. So I multiply by 7, we can cancel out that divide by 7 or the denominator and the multiply by 7. And what we're left with is 2x minus 4. And because we've done the times by 7 on both sides, we've got 14 on the other side. Now again, we work out what the next operation is to inverse. And that will be that minus 4. So the opposite of minus 4 is plus 4. So we're going to add plus 4 to both sides. Again, we're going to cancel out those 2 4s. And what we're left with is 2x equals 18. So now we need to find that last inverse, and because that 2x is 2 times x, we do the opposite, which is divide. So we get 2x over 2 equals 18 over 2. Again, we can cancel out the 2's, and all we're left with is x equals 9. Now I can substitute that back into my equation, and I go through step by step, working out each part. So 2 times 9 is 18, minus 4 is 14, divide by 7 is 2. And we can see that 2 equals 2, so we know that our substitution worked. Therefore, the answer has to be x equals 9. And again, we've tried to keep all those equal signs in a row so the teacher can see each step that I'm doing. So for our reflection today, I want you to think about why it's important to just be doing one operation at a time when we're backtracking. As always, like the video and subscribe for more videos on maths.